Hey, good morning, everyone. Uh, Akansh, recording. Let me check. So, one part of the recording was left for conversion. That's why it was not getting uploaded. I'll just click on it. This should be done now. कल वाली solution notebook upload कर सकते हो उसकी. Amit, which one? Which particular project? This data set, loan data set.
Yes, sir. Loan data.
I'll just put a cap. I'm uploading the solutions. But it will be here. Sure, Akansh, I think one of the recording didn't got converted. It will get uploaded today. So it was done in two parts. That's why. Okay. So were you able to do a revision for yesterday? Quick revision for yesterday? Okay. So what we'll do today is, okay, we'll do a quick revision of random forest. Okay. And ensemble methods in general. Okay. And we'll again solve a problem, but this time we'll solve a regression problem. Okay. So most of the classes going forward and including this will have one practical element. Okay. So don't get disheartened if you're not able to solve. This is the time, to work with everyone so that you can solve the problems here. ठीक है सिर्फ थ्योरी पढ़ के तो आगे इंटरव्यूज क्लियर नहीं होंगे.
Are we increasing the biasness of the model? What are we essentially doing? Are we creating
Just a
some simple
minute.
models, right?
I think that conversion is complete, so Akansh, it will be uploaded now. Okay. So is everyone fine with this particular thing? So we'll have one practical element every day. Okay. So we will be working on one data set every day. Okay. And we have lot of data sets to work on. Right. So should we start for today? Okay. So today we'll be working on a problem. Okay. And when I say you have to work on a data set, the first 15-20 minutes is something you have to come up with the solution. Because if I'm giving you a solution every time, you will never be able to solve it in actual interviews. Okay. So consider out of 4 classes every week, 2 to 3 classes will have such kind of things where initial half an hour you guys spend on one problem, and then we'll relook at that problem and I tell you like which steps are good, which steps are wrong. Okay. So two things. Firstly, if you haven't revised the random forest run, please go to your LMS, spend 10 minutes out there. Okay. And just do a quick revision of the theoretical part. And those who have done, let me just open this. In the supervised learning, you will have random forest. This is the project that we will be doing today, and this is the presentation that you need to do. So just do a quick revision of this, and then we'll do a quick walkthrough again for random forest. Okay. And those who have already done that, I have uploaded one data set and a problem statement. We explain this. So this is a real world data set of New York taxi. Okay. So in New York, taxis are very popular. Like if you might have seen any series, web series also that is based out of New York, like Friends or any other ones you might have seen, right? So now, the yellow taxis in New York were very popular, right? But recently, Uber, Ola, Lyft, all these have, come into place. So these yellow taxi decided that they will create an organization, and what they will do is they will also try to be more data centric like Uber, Ola, and come up with a price prediction. Okay. So what we had done given is a set of data which has one identifier, date and time of pickup, latitude, longitude uh, of pickup and drop, okay, and number of passengers, and finally an amount, basically the cost of the ride. So what you need to do is create a model using these variables to predict the amount. Okay. Now, what do you think this is a type of problem? This type of problem is? Is it a regression problem or a classification problem? Regression, right? Everyone agrees with this, right? Okay. So take first half 15 minutes to explore the data. Okay. When I say explore the data, what you need to do is just look at which variable is what, things like that. Then come up with a baseline model and then you start working around it. Okay. Data set will require some amount of feature engineering. So think about the features that could be helpful. Okay. And then we'll together sit and solve this problem today. Okay. So everyone load this data into the notebook and start with your analysis. Take 15-20 minutes and then we will touch base on what everyone was able to find out. Okay. Now, the dataset which I have uploaded is a trimmed down version of the actual dataset. So, actual dataset had around 1 million rows. The dataset which I have uploaded has only 50,000 rows. Okay. Can everyone start this? So two things, revise this and this. Okay. If everyone has already revised this, if not, spend 5-10 minutes in just looking at these slides. Okay. Quickly go through the slides and we will have a revision also for them. Second thing, start with this problem. It's uploaded on the drive. Okay. This is the location. Okay. Any doubts? Anyone? Everyone clear with the problem? See, if you are not clear with the problem, never solve that particular problem. Okay. So spend time in understanding this. Just to give you a hint, think about what is the most important feature that might be required when you are calculating a fair prediction. Okay. But yeah, firstly understand whatever we have and then we will look at what we can. Hi Faz, good morning. You need to start with uh, a data set called taxi fare prediction that I've uploaded in the drive. Okay, for everyone, let me quickly show you a few things. This is a decision that we will take. Yes, yes. I mean, good observation, Akansh. So, since we have 50, how much? 50,000 data points. Okay. So, you can actually delete this particular thing. And the other thing to think about is, which has no passenger, why were these rides made? Were these rides, uh, I mean, are the latitude, longitude also missing or what? So then it could be that these rides are made to send some parcels or something, right? So not necessarily that it's a wrong thing. Okay. But rows which has amounts in minus, okay, that you can either drop or just use positive amounts. Amount is bit skewed. Fine. From date time, you can extract more features. Think about those. Okay. So move with the usual thing that firstly go into data types, change the data types, okay, as per whatever is required. Then look into the feature engineering part. Okay. Now here, since we have converted it to date time, you will be able to create a lot of features. Okay. So try doing that. Then next thing is what was the most important part, which I told you. The most important part in any fare prediction for taxi will be what? Distance. We don't have that distance variable. So we have to use this latitude and longitude somehow to calculate a distance, right? Exactly, peak time of travel. So do these basic things, okay? Using this date time, you can have morning, evening, sham mein jaise there will be a peak demand, right? Using this latitude, longitudes, calculate distance, okay? Search how you can calculate, okay? Or probably I can also give it to you. This is the function that gives you distance in kilometer. Amount, this is the minimum value which is coming out, which will be obviously wrong. For hour of the day, it is actually from midnight to, I mean, full day is there. Even for day, full month is there. Even for month, so all months data is there. year. Uh, so you have data from 2009 to 2015, day of the week, in 0 to 6. So that means all the weekdays is covered. Travel distance minimum of 0. This is something which we have to check. Okay. The max distance is 8,667 kilometers. Again, this is something which we have to check because see, 1.2, 2.2, and 3.9, but max is 8,667. So could be something wrong here. So this is where we do outlier detection, which you were talking about. Okay. So couple of hints that I have given. Okay. Now we have to work back on it. Right? Everyone got it? Few hints, everyone noted it or not? Yes, no. Guys, जब भी ये practical session हो थोड़ा सा और let's participate more because these are the practical sessions. These are the main sessions that will help you crack interviews. Okay. Okay. So take 15-20 minutes more and just work on these hints. Okay. Just move step by step in a methodological fashion. Okay.
Hello, hello, sir. Hello.
So TensorFlow is a another library that we will use. Okay. What is the error, Akansh? Radiance is not defined. So the way you are calling it, okay, let me show you. But have you done all the other steps? Okay. Are you talking about this radiance? Okay. Sorry. This is nothing but converting degrees to radians. But you can do it on your own also. I mean, remember 360 degree is equal to pi radian. Everyone remembers that? This is one of the way to calculate distance. There are many other ways also. Okay. How are you guys moving? What's the progress? For everyone who hasn't done anything, have a look at my screen. Let me quickly mark attendance and then we'll start. Cheat classes. Okay, so let me quickly read this particular data set. So once you read the data set, okay, everyone focus on the screen for some time. Can everyone focus back on screen or do you want to solve it for more time? Okay, so first thing first, unique identifier is not adding to anything, right? So we can drop that particular variable right away, right? Now let's prepare the data for analysis, and before we prepare the data, let's try to understand the data set. Okay, so what I'll do is really remove all this jazz. Okay, quickly we saw we have 50,000 rows and 7 dimensions after removing this unique ID column, which we don't require. Yes, Akash. Okay. Data set is huge, 50,000 data points. Firstly, with any data, but whenever you are applying, okay, firstly check on a sample data. Okay, so what you can do is like whenever you hit dot apply now, just pass in 10 rows of data and see everything is working fine, then only run on all. Okay, we quickly check the data types. Okay, we saw that this should be not be an object, but should be a datetime variable. And we corrected this. So this is the first and the foremost step that we have been doing everywhere, right? Now, for this particular data set, we might require feature engineering, but what I'll do is I'll kind of skip this for now. Okay. So let me see where we have. Okay. The first thing. Okay. Now, one thing that I should check is, okay, I've converted to date time, but without this also I'll try to create some model. Okay. And that model will be without doing any kind of analysis. Okay. So quickly what you can do is, let's feed in all the data to our model, okay, and see how it is performing. The only check that we will be doing is for the check for missing values, because missing values are not supported by the model, right? So we have to make sure any model that we create doesn't have missing values. This are missing data. Always start with this baselining thing so that you know that now you can create a model. Okay. So missing value check, and we will have our baseline. Okay. Now this is a regression problem. Okay. So first thing that you have to make sure is what kind of accuracy measures we are using. So we'll use three, which is mean absolute error, root mean square error, and mean square of error. Okay. So let me quickly calculate that first. But so you should always be ready with your base models. Okay. Now these base models are created without doing anything. Okay. Let me quickly paste. So split the data into features and targets. So what I'll do here is, since in my case I won't be able to use all, I have to be very selective of what variable I'm trying to use. So I'll quickly use drop taxi head. Everyone is seeing it. Don't focus on your notebook for some time. Focus on mine. Okay. Everyone is seeing on Zoom screen, right? Yes, no. Okay. Then I'll give you enough time to practice. Don't worry. Okay. This session is only for practicing only. Okay. So always have this baseline model. Okay. When I give you those 15-20 minutes, try to get this baseline model as soon as possible. Okay. Can we make that a habit? ठीक है. सबसे पहले क्या करना है, डेटा सेट लोड करना है, डेटा के टाइप्स चेक करने हैं, फिक्स किया, check for missing values if there are any, either remove or impute, ठीक है, based on whatever things we have, ठीक है. Then create a baseline. In fact baseline model के लिए missing values को पूरा उड़ा ही दो छाप, if there are no more, or drop the columns, whatever, ठीक है. Now in this case I cannot use this date time variable because for a model to work it doesn't accept this date time variables at all. Okay. तो सबसे पहले अपना प्रिडिक्टर और टारगेट, ठीक है. नेक्स्ट थिंग इज स्प्लिटिंग आवर डेटा इनटू ट्रेन टेस्ट, राइट. So we have around 35,000 data here, 15,000 data in our test. So this is, I'm using random forest regressor, but we all know what we can use, right? So what have we learned before in regression? Regression हमने और कौन सा पढ़ा है? Can anyone tell me quickly? Yes. So we can always use linear regression. Now tell me how to use. Anyone remembers कहाँ से linear regression को import करना है? ठीक है. So there are two ways. I'll use sklearn dot linear models. Okay. So for baselining, I'll first do a baseline with linear regression model, and then I'll do with a random forest regressor and a decision tree regressor. Okay. R is equal to linear regression and L. By the way, this time what we can do is let's create a function which does everything and gives us the values. Okay. Why to write different functions for every time, right? Functions are meant to maintain, have repeatability. So I'll write a function which does training and evaluation, both. Okay. What it needs is the model. Okay. It needs these four data set: X train, Y train, X test, Y test. I think that's all. And the work of this model will be, it will firstly fit the data, model dot fit, then it will predict, then it will do predictions. So model dot fit, model dot predict, then finally we calculate accuracy measures, which is on this Y test and Y pred. Okay. And finally, these are being created. So I'll quickly rename this. Let's see. And finally, this particular model will return MAE, MSE, and RMSE. Cool. One function to do everything. Okay. Now all I will need is, so what I'll call this is, I have created a training template. Now all I need to do is initialize this particular model. Let's say this is my initialization, and I'll call this particular method training evaluation, and instead of this model I'll pass in LR. Okay, and I should get these particular values as return. Let's see if, okay, my bad. Quickly I got scores with this. I have to check for random forest now. Let's check for decision tree regressor. So how do we call decision tree regressor? Anyone remembers? In case you don't remember, that's also fine. I mean, there's no harm in it. Yeah. So from sklearn.tree, we need to import decision tree regressor. Go quickly here and call this particular thing as is. So instead of this, I have to call decision tree regressor. I'll rename this model as DT. Okay. And pass this DT here. Okay. So with just two lines of code, I'm not doing anything. I mean,
With linear regression, I'm getting RMSE of 9.69. With decision tree, I'm getting 6.59. This is all by default without doing any other thing. Last one is I'll call our random forest regressor. Okay, let me do few more changes. I'll just move this code above and this is baselining. Fine. This is fine. Training template is not required. So that everything, just see this particular thing. You should organize your code always. Okay. That's why I code in front of you so that you also can take those things. Ref. Again, we haven't tuned these models. Okay. We are just using as is. Amit, where do we check precision recall? In which type of problems? Are we doing classification here? No, right? This is a regression problem. So you look at MSE, RMSE, log RMSE, things like that. Okay. So if everyone can see, this is my benchmark model. I'm getting a RMSE of 4.9. Okay. Just without doing any any jazz. Okay. So saying that latitude longitude is not helping us at all is not totally correct. Okay, because RMS is not that much if you see. Okay, but we'll try to build more better models. Okay, and then let's see how things move from here. Okay, so everyone, please, when I am giving you those 15-20 minutes, please reach this baseline model step always. Okay. And see, ये optimization ये बार बार क्यों कॉपी करना है? Now we are done. I mean, कितने भी मॉडल ट्राई कर लो, सिंपल ही है. Okay. So I want to try few more models. Just give me a second. We'll try all the models that we know in regression out here. And what I want to show you is it's a quick thing. Okay. Any other regression model that you know of that we can try? So there is a model called ADA boost regression. Okay. So let's try that also. Okay. And then we'll come to XGBoost is a different animal altogether. So I've kept XGBoost for next week. Don't worry. We'll cover that also. We'll use something called ADA boost regressor. Okay. And then let's look for gradient boost and bagging regressor. Let's quickly import those model also. The one is our bagging regressor, ADA boost regressor, a gradient boosting regressor. But let me tell you again, changing these models won't help much. Okay. The main thing that will help you here is, uh, a valid feature engineering that will give us better results rather than doing these things. But just for our baselining, what we'll do is we'll try them. Okay. One is our add our with this particular thing, it becomes really easy. So add a regressor, all we need. Then I'm just copying this. With data boost, although this should have been good, it is performing worse than this. Then we have gradient boosting. Gradient boosting is very equivalent to XG boost. Okay. Thing with this, why these are not performing good is because you have to fine tune their parameters also. Still, random forest is the best one, and random forest is actually a very good regressor. Bagging, bagging this. I told you about there are two techniques. One is boosting and bagging. So random forest and bagging regressor as from those bagging techniques, and gradient boosting and the boost and XG boost are boosting techniques. Okay, so generally, if you see bagging techniques are giving me better result than boosting techniques for this particular problem with this particular data as of now. Okay, cool. I can create even a function where I don't need to pass in this. Okay, I can create one more function on top of it. All I need to do is just define which models I want to use and I'll get a report of all the models. So you can do that level of integration also. Okay. Is everyone fine? Yes, no. Can all of you also try these baseline models? Okay. I'll quickly tell you from where you need to call them. Okay. And what I'll do is I'll copy all the code so that anyone who is stuck at least can come up to this point. Okay. And maybe all of you can copy this and then start writing your code. Let me quickly copy this. Just make sure when you're copying, it won't run as is because this is a notebook and I'm copying it somewhere else. Okay. Just copy the code part. If you will copy everything like this, it will throw some error. Okay. So I'll quickly remove this also so that you can run as is. So any multi-line comments, just remove them. So you can copy or refer the code from here. Okay. So everyone, please come till this particular point, create your baselines, and then let's move from here. एंड कहीं पे टेम्पलेट सेव कर लो, ठीक है? कोई भी प्रॉब्लम तुम्हें स्टार्ट करनी है, ओके, यू कैन क्विकली डू दिस. This content heads, this one, this headings, Chaitanya. Okay, so what you need to do is, so close your Jupyter and install NB extensions. Okay, so there is a for installing NB extensions and whatever Windows or whatever you have, Mac OS, Windows, Linux. Okay. So once you install this and restart your Jupyter, okay, and it's very simple to do. I mean, you can use this particular command to do that. So whatever is your command line, okay, if you're using Windows, search for Anaconda prompt, okay, and in this particular thing, just go and write this particular command, okay. But firstly close all your Jupyter and everything. Once you install this, click enter, it will install this. Then from the start menu again, open Jupyter Notebook. Okay. Don't open that navigator and everything, and you will get there. Inside this NB extension, you can have a lot of things. Okay. So collapsible heading is the one which we use, and table of contents. Okay. That way, I mean, easy to navigate things, right? Glad someone asked this question because this is a very helpful tool. I mean, I didn't know it 2 years. Since last 2 years, I'm using it, 2.5 years. Before that, I didn't know. There is one more important, I mean, a very good extension called Moped. There's something called Roughpad. I mean, that's also very good extension. Okay, so what you need to try now is, okay, we have done these things. Now do some feature engineering about those distance and all variables. Okay, and make sure when you are passing this, you are converting it to NumPy to make it faster. Okay, if not, it will be slower.
Okay. And then finally, we'll try to train our model using these. Okay. We have done some other analysis also, correlation studies. Obviously, latitude and longitude uh, will have a lot of correlations. So as of now, whatever we did was, I mean, we just passed everything as is, but try to do some feature engineering and then let's see what are our results. We should be able to beat whatever we got initially. Okay. Okay. Can everyone try this, or do you want me to do all those things also? Let's give it a try. Okay. So distance use karo, see which variables do you want to keep in the model, and then we'll apply grid search on all these. Okay. So the way you will use date time is to extract date and time things from them and then pass it as a predictor. Don't use the date time variable as is. Okay, that's why I had to remove that particular variable because it will show me an error if even if I try to do. Okay. Ansh, does that answer your question? Also, uh, if you want to use XGBoost, you can do that. Okay. Oh, codes is nothing but for date time conversion only. I mean, so what happens was when we used to do in early days of Python, okay, when you used to do a conversion from int to float, okay, so it basically what it does is it just makes sure that there is no information lost when we are doing that particular conversion. At times you will have few values that are not getting properly converted, so it makes an approximation to do that. Okay.
what you can do is check this. Always check for the official documentation, and you will get exact why and what was used. So if you see, uh, out here, one raise is the default choice where it will raise invalid percent. Okay. Ignore is totally ignoring. Okay. And this course will set the invalid outputs as NAT, which is nothing but similar to null. Okay. So that since we are applying it on a huge data set, it doesn't stop in between. Okay, in case you want to use XGBoost, I mean, you can use it here. Even XGBoost won't be as good as random forest in this particular example. The reason I'll tell you when we cover XGBoost, because boosting algorithms work in a different way. You might have get different result, but you should not get so many much different because it's a random evaluation. Then that's fine. Let me run it again. See how he also got 12. Let me run it once more. I got 7 now. So it's a random thing since I haven't used any random state out here, so we both can get different results. Fine. You just saw, right? I reran, I got 12. So that's fine. So that's why we use random state. For baselining, I didn't use anything. Guys, any update with the distance metric? How are we getting results now? And by removing all the nonsensical data. Two things, distance and outlier treatment.
Taxi distance traveled, apply lambda A is greater than 18 in a in A 18.00 in A. Why are you doing this?
वो एक वैल्यू आ रही है ना मैक्सिमम वो 8000 कुछ की, तो वो मैं देखना चाह अगर
इन ए कैसे? इन ए तो ये यूज नहीं करोगे ना, अप्लाई करके प्रिंट नहीं होता है। मतलब प्रिंट भी होता है अगर तुम एक सेपरेट फंक्शन में करके करो तो, बट दिस इज नॉट द वे टू यूज अप्लाई फंक्शन। Okay, so let me do this. Let me also create that particular feature. Okay, यहाँ पे हमने डेट टाइम्स डाल दी है, and then we added this distance one also. तुम्हें ये ट्रैवल डिस्टेंस को चेक करना है, which is greater than 18. उसके बाद उसका क्या करना है? What do you intend to do?
सर अगर ज्यादा वैल्यू होगी नहीं होंगी तो ड्रॉप कर दूंगा, अगर होगा तो फिर चेंज कर दूंगा।
18 से ज्यादा बहुत सारी वैल्यूज होंगी, तभी ये हैंग हो गया।
18 सर मीन आ रहा है ना, मतलब एक आउटलायर्स की तरह काफी बड़ी वैल्यू है तो
मीन तो ना यूज करोगे आप, ये हम 18 यूज करते हैं तो कितना रेट है? चालीस पचास हजार ऐसे ही है। 40-50 नहीं, मतलब काफी थाउजेंड है। ठीक है, तो ऐसे मत करो कभी। 922 रिकॉर्ड्स तो ना ड्रॉप करोगे, ठीक है? तो चेक द डिस्ट्रीब्यूशन प्रॉपरली एंड देन डिसाइड, ठीक है? नाइक्योर वाला मेथड देखा था हमने, राइट? यूज दैट, ठीक है? या फिर दूसरा तुम ये भी कर सकते हो, इसका IQR जो होगा, व्हाट विल बी द IQR ऑफ दिस मेथड जो हम यूज कर सकते हैं, वो ये है p डॉट परसेंटाइल। लेट्स कैलकुलेट द 95 परसेंटाइल। 95 परसेंटाइल 10 के आसपास है, 99 परसेंटाइल 20 के आसपास है, तो प्रोबेबली 20.77 माइट बी अ गुड थिंग। ठीक है, इसमें भी ज़्यादा है तो हम थोड़ा और आगे जाते हैं। बेसिकली हमें वो जो एक्सट्रीम वाला है बस वो हटाना है, क्योंकि एक्सट्रीम ट्रिप्स तो होंगी ही, जैसे कि 99 पॉइंट पे 866 कुछ आ रहा है, प्रोबेबली एनीथिंग ग्रेटर देन 1000, ठीक है? दैट वी कैन सी, इनफैक्ट 1000 से भी और बड़ा, क्योंकि मुझे ज़्यादा ड्रॉप नहीं करना है। ये 87 जो भी आ रहे हैं जिसका 5000 किलोमीटर से भी ज़्यादा था, आर दीज वैलिड और नॉट? इनके लिए कोरिलेशन देख लो डिस्टेंस के साथ, सॉरी अमाउंट के साथ। ओके, सो यस्टरडे हमने बहुत सारे प्लॉट्स देखे थे। यूज दीज प्लॉट्स, ओके, any of these plots to identify if things are good or not। जैसे हम ये वाला प्लॉट लेते हैं, क्योंकि मुझे देखना है कि जो हमने डेटा सेट लिया आगे का, इसमें कोरिलेशन है या नहीं है। आइडली जितना ज़्यादा डिस्टेंस उतना ज़्यादा वो होना चाहिए ना, राइट? यहाँ पे क्या करते हैं, यहाँ पर लेते हैं डिस्टेंस ट्रेवल, यहाँ पे ले लेते हैं
कॉस्ट
अमाउंट है ना, क्या नाम है ये?
और एक में फुल डेटा पे चेक कर लेते हैं और एक हम सिर्फ और सिर्फ उस स्पेसिफिक डेटा पे चेक करेंगे। इसमें टाइम लगेगा क्योंकि डेटा सेट बहुत बड़ा है। What we can do is just use a subset of the data. So I'll just use this data set. तो यहाँ पे तो मुझे कोई कोरिलेशन दिख नहीं रहा है। क्यों? क्योंकि कुछ पॉइंट्स यहाँ हैं, अमाउंट देखो कितने कम है, इसके अमाउंट्स भी देखो। तो दैट पर्टिकुलर थिंग मीन्स इज कि ये मोस्टली जो डेटा है 5000 से ऊपर वो बेकार है। ठीक है। द अदर वे दैट यू कैन सी इज अमाउंट और ट्रैवल डिस्टेंस में कुछ कोरिलेशन दिख रहा है या नहीं दिख रहा है। अगर वो सारा ये जो ट्रेंड है, इफ दिस इज सेम अक्रॉस ऑल द डेटा, तो फिर टाइम लगेगा। फिर डिस्टेंस कैलकुलेशन, अरे नंपाई पे करो, होएगा। देखो 1 सेकंड लगता है उसको। बंद करो, क्लोज करो, यूज द वन विच आई एम गिविंग यू। I'll do is I'll just copy it here. एंड में मैं कॉपी कर रहा हूँ, just use that. Okay, copy this particular thing. I can't. Okay, numpy पे नहीं करोगे तो बहुत टाइम लगेगा कैलकुलेशन में। That's why I said 5 डेटा पॉइंट्स पे पहले ट्राई किया करो कोई भी फंक्शन। अब जैसे यहाँ पे मैं अप्लाई कर रहा था, तो मैं एक स्मॉल डेटा सेट बना लूंगा विच इज टी एफ टैक्सी का सैंपल, जिसमें से 10 रिकॉर्ड रखूंगा और फिर मैं ये चलाऊंगा फंक्शन। ठीक है। उसमें देखूंगा अगर उसमें 10 के लिए मुझे 1 मिनट लग रहा है, तो 50,000 के लिए सोचो कितने मिनट्स लिए। तो दैट मीन यू हैव टू ऑप्टिमाइज द वे यू आर राइटिंग फंक्शन। बहुत बड़ा डेटा। The bad thing about this big data set is वहाँ पे C1 जो होता है फेल सा हो जाता है, इसीलिए छोटे डेटा सेट्स में तो इज फाइन। आई मीन इट विल गिव यू ऑसम गुड प्लॉट्स। रिग्रेशन प्लॉट और करके देख लेते हैं। Create that. इसमें भी उतना ही टाइम लगेगा। इसमें भी कुछ ढंग का कोरिलेशन तो दिख नहीं रहा है। ट्रैवल डिस्टेंस और अमाउंट्स में अगर तुम देखो तो कुछ ज्यादा मिल नहीं रहा, तो प्रोबेबली ये वेरिएबल इतना इम्पोर्टेंट अच्छा भी ना हो. एंड डू यू नो व्हाई दिस इज नॉट हैपनिंग? क्योंकि हम जो डिस्टेंस कैलकुलेट कर रहे हैं, हम 2 पॉइंट्स का डिस्टेंस कैलकुलेट कर रहे हैं.
तो सर वो तो पिकअप और ड्रॉप के बीच का ही डिस्टेंस होगा ना, तो उसी का तो अमाउंट ले रहे हैं ये लोग।
सिटी में ये बताओ, तुम ए पॉइंट से बी पॉइंट जाते हो, तो हम उड़ के तो नहीं जा रहे ना. टैक्सी से लेंगे तो बहुत लेफ्ट राइट से होंगे, राइट?
यस।
वो कैसे अकाउंट होएगा, है ना?
बट सर वो तो डिस्टेंस में हो जाए ना, चाहे लेफ्ट जाओ राइट जाओ, तो डिस्टेंस ही काउंट
कैसे
होगा।
आएगा?
सर वो
तुम्हारे
तो
पास ये
स्पीडो
पॉइंट है, स्पीडोमीटर. स्पीडोमीटर का डेटा तो नहीं है तुम्हारे पास. तो ये देखो, जो डेटा सेट है अपने पास, इसमें तुम्हारे पास डेट टाइम ठीक है, बट ये लैटिट्यूड लॉन्गिट्यूड से तो तुम्हें पता चल रहा है ए पॉइंट और बी पॉइंट के बीच में, और हम दोनों के बीच में सिंपल डिस्टेंस निकालते हैं. ठीक है.
समझ में आया सर, वो डिस्टेंस तो वही होगा। आप कह रहे हो लेफ्ट राइट टर्न से कुछ बढ़ जाएगा डिस्टेंस, या क्या होगा?
सिंपली देखो, गुड़गांव टू लेट्स से आगरा देख लेते हैं. ये जो दिख रहा है तुम्हें, हम लेफ्ट राइट इधर उधर जाके यहाँ पहुंचते हैं, राइट?
यस सर।
और जो हम कैलकुलेट कर रहे हैं वो इन दोनों के बीच में सिंपल लाइन कैलकुलेट कर रहे हैं, है ना? वो डिस्टेंस तो नहीं दिया हुआ हमें, तो ये पॉइंट दिया हुआ है, ये पॉइंट दिया हुआ है. ठीक है, जैसे इसके बीच में निकालते हैं.
अच्छा, हम शॉर्टेस्ट डिस्टेंस निकाल रहे हैं सर, वो सीधा स्ट्रेट लाइन से।
हाँ, हम तो शॉर्टेस्ट निकाल रहे हैं. हम ये कहाँ से कैलकुलेट कर रहे हैं कि उसके लिए पूरा इतना घूम के जाना पड़ रहा है? हम तो ये देख रहे हैं, ये पॉइंट स्ट्रेट लाइन खींचो यहाँ पे, तो कितना डिस्टेंस आएगा,
ठीक है सर।
राइट? यहाँ पे हुआ ना. हाँ, ये पॉइंट है हमारा, ये पॉइंट ए, ये इस बी, इसके लैटिट्यूड लॉन्गिट्यूड, इसके लैटिट्यूड लॉन्गिट्यूड. हम जो है सिंपली ये डिस्टेंस कैलकुलेट करें, सिंपल स्ट्रेट लाइन. ठीक है, तो इसलिए हो सकता है कि अब यहाँ से यहाँ पहुँचने के लिए बहुत घूम के भी आना पड़ रहा है.
यस सर।
मान लो इस रूट से आ रहा था. हम्म. यहाँ पे हम थोड़ा बहुत तो डिस्टेंस में फिर भी वो करते हैं. ठीक है, not exactly displacement, we are using ever seen formula for calculating this. इससे क्या होता है, एटलीस्ट स्ट्रेट लाइन नहीं होएगा, स्फेरिकल डिस्टेंस तो कैलकुलेट होगा, बिकॉज आवर अर्थ इज स्फेरिकल. If you guys want to take quick 5 minute break, take a break and come back. Okay, but at least tell me the RMSEs that you are getting with these features. अब तो सारा कोड मैंने दे ही दिया है. ठीक है, डेट टाइम का तुम्हें एक डेट टाइम में कन्वर्ट करना है. ठीक है, डेट टाइम में कन्वर्ट हमने पहले ही कर लिया है. बस ये आर, डेट, मंथ और डे ऑफ द वीक निकालना है. इनको डाल के बस एक बार ट्राई कर लो कैसा आ रहा है मॉडल. दैट्स इट. For these also what we can do is can create one function which has all my models. So now all models. ये हमने स्केलिंग विलिंग कुछ भी नहीं किया वैसे. के अंदर all I need is you to pass this particular data, and what I'll do is कितना इसमें डाल देता हूँ. And this will be what linear. Beautify करने का है. I'll just try this. Or in fact, what I can do is make simple all models कि हम बना लेते हैं dictionary. If it works, then I've done for all the modules. ठीक है, मतलब आई एम जस्ट इम्प्रूविंग माय कोड. ठीक है, all I wanted is this particular thing. This works. I'm just creating one function which has everything. Okay. And what it does also is it returns us all the values and everything. All models in one. Okay. And let it calculate. With this one thing, I can calculate everything in one go. So all I need to now do is do some feature engineering and call this particular thing again so that I get all what is required. Okay. So एक ही गो में अपने पास सब कुछ आ गया. ठीक है. Just for quick comparison, we know random forest is working the best out of all. Okay. So just एक बार की मेहनत है. ठीक है. But now we are done. Okay. So we did some feature engineering now. ये सब calculate करते हैं without anything else, just with these features. Okay. Let's try to create a model. Okay. Now, firstly, I won't use distance. I'll just use these features. Drop this variable. Okay, so I have these variables again are date, time, year, day of the week. So what I'll choose is again use these features apart from date, time of the pickup. Okay, because I have replaced all these features with this and then create a model. Okay, so let's go back to splitting of the data. This is here. Here, feature engineering. Using date time as predictors. Now we have 10 particular variables as my predictor as compared to our older 5 predictors because we have created so many. And if we look at extreme ahead so that we know what we are using. So what we are using is latitude, longitude of pickup and drop, number of passengers, hour, day, month, year, and day of the week as my training data. Okay. Now it's all simple since we have defined everything. Just for this particular thing. Models. Before I call, I'll just create a dictionary. Models, feature, engineer. With linear regression, I got 9.6. Okay, with decision tree 6.8. Let's see for other models. Four point seven eight. I think this 4.96 was our earlier benchmark, and this one is slightly better. Okay. I think the best one is random forest and then bagging. Like I said, bagging algorithms will beat in such kind of data. Okay. Okay. So now let's add this travel distance and then see how is our model performing. Okay. Simple, same cheese करनी है, ठीक है. We have done this particular thing, so I'll just here. Yeah, we should use. Why don't we? Actually, we should. My bad, I haven't added it. I'll add it abhi. Take it. We should always use random state. My bad, I didn't use it yet. Okay. Because I was just creating a baseline model. Generally, I always use that. That ensures consistency. Okay. So yes. So we have added one more variable to our train data. Okay. Which is this distance variable, and then let's create it. One thing also I'll change in the function is I want to return the functions or the models also. So once I have the models, I can test them. I can look at feature importance and everything. Okay. Quickly change this particular thing to have model, and this model will have nothing but LR. PDT. So yesterday we looked at feature importance, right? So let's look at all those things again. With this, I am not getting any improvement. 4.6 it is only. But with other backing and other classifier, we got better. Actually, now you see XGBoost is actually winning with 4.6. This is the minimum for this. Okay. But yeah, here I got the minimum of 4.7. So adding distance and using XGBoost has helped us a bit, okay, in improving our score. But let's look at it now. Let's look at the feature importance. So I'll just rerun this because now this particular thing will have all the models also. As of now, I've used all. Okay, I'll tell you why. I wanted to look at feature importance and then select my variables. And just like exactly, you should try that. I mean, what and why?
I have used both accounts when we added the distance now. So I added all the variables. Okay. 4.6 gradient boosting is also now doing good. Correct. So I have these models with me, right? So what I'll do is, okay, I'll pick the random forest model and just look at the feature importance. Since it's a dictionary, I can access all the things like this. This model, what all the feature importances. Let me quickly use the same diagram we used yesterday. Okay, so seems like travel distance kilometer is one particular variable that is helping us a lot, and all the other variables are not playing any important role, at least when we are looking at our linear regression model. Okay. Now let's look at one more thing, which is from our linear regression model. Okay, so for linear regression model, let's look at these coefficients. And let's also look at 4. So with linear regression model, one thing is quite clear. The R square is very less. So that means linear regression the model is not fitting in at all. Okay. With random forest, we are seeing some things. Maybe I can put a threshold since traveling distance kilometers is one of the features that the model is getting obsessed with. So we might have to look, whether we should include or exclude that particular thing. Okay. So next thing that you can try is, and that you should try is removing outliers. Okay. Did anyone try removing outliers? And also, I think one model that I can particularly create is without by excluding two variables. What I can see is I can remove all the latitude, longitude columns. So easy way will be for again. I have these variables, which I will do this. And then let's recreate our models with by removing all the latitude, longitude parameters. At least my random forest model should be better.
right? But let's see. Yeah. So we got, oh, actually, the best one which we had was 4 point something. So we got something around 5.1, which is not very decent. And I think with latitude, longitude, it was still playing some important. Probably removing number of passengers is not having any kind of role. That's what I think. So what we can do is recreate one model, drop number of passengers. And this is without doing grid search, without doing outlier treatment. I have a feeling once we do the outlier treatment, we should be better. Good, 0.6 is the best one which we have from this. And the last best was what? Adding distance. 4.6 is the best that we have till now, right? 4.68, 4.62. I mean, all the models are quite close only. Okay, so now let's do our missing value treatment and then see how are the results. Is everyone following with me? Is this, are these, I mean, what I generally want is you guys to practice with me, okay? And you tell me what to do. So, what do you think now next we should do? Because we are still left with, you know, doing all the outlier treatment. Okay, so let's try outlier treatment. Everyone with me, along with me. Okay, now what we have proposed out here is these outliers. Okay, so let's quickly do this. Three, four these. Okay, and form our data set. Treatments. Based on this, we came up with our. Now let's keep fair. We are left with this. Second is we remove actions. We are left with around almost same. Then we are removing left and long. Calculated how many incorrect were there and finally filtered the data. And let's now create our model with missing values treatment. RMSE of our linear regression is still the highest. Last, we will do this correlation study to see if we can remove few variables. So maybe when we are using latitude and longitude, we can pick one of them. And we are yet to see all this P cars and everything. So we were successfully able to reduce from 4.6 to 4.4. So every one decimal point, matters a lot. 4.6 से 4.4 पे हम आ गए and we started with what, 5 or 6 6 का RMSE, right? Cool. Everyone with me till here?
So 75% of amounts are under 13. In that case, RMSE of 4.4 is still very high. Yeah, yeah. I'm not saying it's very good. See, like I told you, this is a sample data set from original data set of 1 million records. Okay. So in case you want to try it out, this is the original data set. See the data set size also. Okay. In fact, you won't be able to use the, I mean, this whole particular thing because the data set size is so huge, you know. So 261, in fact, more than 1 million. I was wrong. 56 million records, and I'm using 50,000. So, and with this also, I mean, if we just check the leaderboard, these are the RMSE scores. So, this is when they are using all the data, 2.8 or 3. We can try it on test set. Yes. What you can do is download this test set and you can submit your predictions. Exactly. Just apply the same set of things that we applied here and just do that particular thing. We have all the longitudes, latitudes that we can use. Key here is nothing but those date time variables that we have. I mean, it's not over. This we have just started it off.
I mean, you will have to spend more time on it and see where we can go. Okay. If we see now, uh, so the RMSE of 4 or 4.4, what does that mean is that we are off by plus minus $4. Okay. Which is huge if we consider the rupee format, right? Cool. What more we can do is probably you can look at removing number of passengers, and the other correlation that we can do that I haven't done yet is instead of hours, use time of the day. Okay. So we can create one more variable, again part of feature engineering, which tells you that morning में, evening में, afternoon में, night में, what are the different caps. Okay. And then use that variable, उसको dummy encode या label encode करके, then we can try how my model is performing. Similarly on day of the week, weekdays, weekends. Okay. So for that, again, before we come to correlation analysis, let's look at some of these pieces. Let me just copy it and bring it up. Let's look at more EDA and feature engineering. First thing that we'll be looking at is peak hours. Okay. And that too during weekdays and weekends. So do we see some kind of trend out here? Okay. This is for week. So week May, the main, in the night time from 0 बेसिकली रात के 12 बजे से लेकर सुबह 6 बजे तक द डिमांड इज लेस. 6 से जैसे ही 7 बजते हैं द डिमांड डबल्स एंड देन पीक्स आउट टिल 9 AM. सो ऑफिस आवर्स एंड देन इवेंचुअली पूरा पूरा रहता है, ठीक है, बिकॉज रात में लोगों की पार्टीज, ऑफिस से आना एंड ऑल दोस थिंग्स. ड्यूरिंग द डे 3-4 बजे के आसपास थोड़ा सा ड्रॉप होता है, बट देन दिस इज देन मोस्टली कंसिस्टेंट. Only this particular part is a lot different from this. Now let's see the trend during weekends. Weekends पे see the ulta. Parties होती हैं, right? New York is a party place, and there you can see a lot of parties in the beginning and less in the night. So that means using this, I can create two variables. First, weekday, weekends, that will be my one variable. Second variable that I'll create is these 10. So 0 to 6, one bucket, and 6 to rest of the day, another bucket. Or maybe 0 to 7 as well. Or maybe I can divide it into 3 buckets. Can you guys try it? Okay. Is everyone fine? Do you want to practice from here? Can you take it from here? Yes, no, lost. Am I audible properly? Or you guys are lost, or you guys are seeing, or what? Okay. Lost in different variables. That's fine. See, ये जो data sets है ना, ठीक है? I mean, these are good data sets that we have. I mean, 50,000 lakh वाला तो बहुत अच्छा data set होता है to work on. Okay. Let's do this ना. ये तो हमने देखे. ठीक है. Let's create two variables. It's easy. So what I'll do is, I mean, you guys all should do it yourself, but I'll still do it. So one is weekday or weekend, right? So day of the week की जगह हम एक वेरिएबल बना लेते हैं which is weekday or not, right? So weekday 1 is weekday, weekday 0 is weekend. Okay, fine. So weekday, which is nothing but the taxi dot apply lambda x 1 if it's day of the week greater than, or probably I can do is greater than equal to 5 is 0, which is our weekend. वैल्यू कॉन्स को देखते हैं. अच्छा, one thing that we can also see is on an average any hike in in our amounts. So we there's a variable pass करते हैं, and then we take amount, and then we take mean of it. On an average weekday weekend पे ऐसा कुछ चेंज नहीं देख रहा, but हाँ mainly I think hours के basis पे होएगा, क्योंकि that's how we see here also, right? Uber and all में we have different variable values for different time rather than days. ठीक है, weekday weekend का अलग होता है. Holidays might be, could be one thing where you are charged extremely high and extremely low, that we will see. Okay, so weekday पे तो ऐसे कुछ नहीं मिल रहा है. Next pattern that we should create is let's split into morning. Morning is till 7 a.m. or maybe night. Let's call this night. Early morning, maybe. Early morning till 7 a.m. And then we call this as morning till 12, wherever it peaks. Okay. Or maybe at 11, 11, 12. Morning, okay, 7 to 12. Then we have 12 to 6. Then 6 to midnight. Let's have these four variables. Okay. So do you think should I use something simpler to calculate these four values? What can we use to split? How can I split my one particular column, which is nothing but uh, this is R of the day, into these one, two, three, four variables? ये तो पाइथन है, ये तो कोई भी बता सकता है. Can anyone help me with this? मल्टीपल कंडीशंस के लिए हम क्या यूज करते हैं? if else one way is पूरा if else का ब्लॉक बनाओ and do this. There is one more efficient way. Okay, that is called np.where. ठीक है, इसमें क्या होता है? For example, if I have to create the same thing using this, so yeah, हमने day of the week use किया था, right? Greater than 0, let's say this is else. Okay. So using just this particular one statement, I could have done this easily. Okay. And इसी के अंदर हम एक group by कर सकते हैं. So what I'll do is I'll use this now and assign to a variable. Okay. So I'll use R. Okay. The first condition that I should check is if R is less than 7. Okay. This is nothing but my early morning. Okay. So just to show it simply, so rest early morning हमारे पास सारे variables आ गए. Second condition that I have to check, so I'll add it out here only. Instead of this, next condition is check if it is less than 12, then it should be called morning. Next thing that is checked is if it's less than 6, it's afternoon, maybe evening, and call this as morning. And actually, this is evening. 6. Acha, one thing to note is I'm checking for less than 7. Okay. Now 0 is also part of this. Okay. So I'm considering all the 0 ones. This particular are also part of this. Okay. So 7, 12. Okay. Now 6 will be what? 18. And lastly, मुझे कुछ check करने की जरूरत ही नहीं है. Everything that is left is evening only. Okay. Some brackets are missing, nothing else. This is one bracket. अंदर जब हम आएंगे तो this will be another bracket. So one on this particular This is one. This is second bracket. Oh, messed up in one of the brackets. Let me quickly check this one now. So this is checked. Now inside this, I'll have another condition, which will be np.where. Here I have to check. Now things are fine. Okay. So with just one line of code, I'll get everything. np.where, and this is our categorical variables. I can say that. Okay. So I got a split. Okay. Yes, 18. Yeah. Next thing that we should try out here is, let's do a group by and check whether these things are adding up to our estimations or not. I'll do a group by on weekday. Another variable is our cat. Check amount and check mean. So although the number of cabs and cab demand is different, but the average price is high for early morning. Weekend is bit high only. On afternoon, okay, weekend is higher because afternoon में weekday में कम होते हैं, right? And then evening में again weekend will be charged slightly higher. But yeah, that's it. What the difference is. Okay. Now your job will be to use this variable and finally see if we can beat the existing accuracy or not. Yes. We could have done that, but if you are planning to assign dummy variables, then that makes sense. Okay, so what Akansh is saying is that instead of this, what if we make these variables like this? So let me do it. What I'll do is early morning को हमने 0 बोल दिया, morning को हमने 1 बोल दिया, afternoon को 2 बोल दिया, evening को 3 बोल दिया. ठीक है, तो हमारे पास 0 1 2 3 आ गए instead of this. Now what if I can create a model directly now? ठीक है, but if you want to do dummy encoding, then that it won't help, right? 13 variables हो गए. Let's see if we get anything better with this.
Still हमारा 3 तो रहेगा, I mean 4 तो रहेगा ही फिर भी. 4.4 is something which we have reached. So nothing major improvement that we got. In fact, this was almost equivalent to this. So next thing could be grid search. Okay. And probably looking at more such features and trying with dummy encoding features. Okay. So yes, definitely. It does make a difference. See, ideally, get dummies is a better way. Think about this, no? So if you are doing 0, 1, 2, 3, you are adding a biasness to the model. What you are saying is 2 is higher than 0. This is what it means, right? So till the time we don't have, and any tree-based model work very good on categorical data. Okay. So if we add more categories, okay, it might be better, but it could be worse also. And we haven't applied grid search anywhere yet. So that is one more piece that is left out that you need to try it out. Okay. So I'll give you this notebook. Okay. And mention steps to try. Okay. And in rough, I have some miscellaneous things that were done. Okay. Correlations, you can see all other plots. Okay. And modeling part we have seen. This is the grid search part. Okay. You can use this and come up with a better number. Okay. Let me mention some of the next steps that you can try. So one thing that you can try is definitely create use dummy encoding, standardizing, transformation of target variable, and then obviously your grid search and more features. Probably these 4 or 5 things I can think of right now away that you can and you should try. Okay, so just for this one, let's look at one thing. This is the distribution. So with the log transformation, I am expecting to get a better score. You all get it why, right? So let's try also. I mean, since we have some time, so why not? Let's try this. Don't get fooled by this RMSC. Okay. You all know the reason, right? Point 0.5 आ रहा है because we have done a log transformations. Okay. But it seems decent. So let's see, let's use the random forest model and do exponential and check the actual values. Okay. So this is my random forest regressor model, right? What I'll do is dot predict my x test. Okay. And then I'll do np.exp of these values. Okay. Treat it as white, red, white. Even the log transformation is not helping us a lot. Sorry, my bad. This also needs to be done. It is coming out to be 4.4 even after a log transformation. At least with the random forest. So we can try with other models also and see. Okay. Cool. So everyone just go back, okay, today and try this things, okay. Use of these, okay, and see if you can still get anything better with this. Fine. Any questions anyone has? Any question, anyone? Okay, so let's meet on Thursday. Okay, until then, please practice. Okay. Okay, thanks everyone. Thank you.